Hello viewers, in today's session we are going to discuss another important problem from application of derivatives related to increasing and decreasing functions. So here we are going to solve this problem where we have to show that f of x, which is x minus greatest integer of x, is an increasing function in the open interval, that is 1 comma 2, right? So here we have to prove that the function f of x, which is the difference of x and the greatest integer of x, is an increasing function for all x belonging to this interval, that is 1 comma 2. So let us start. So now let us first take the definition of an increasing function in terms of derivatives. Suppose we have a function, say y is equal to f of x, and if this function f of x is continuous in the interval, say a comma b, and it is derivable in open interval a comma p, then this function is said to be an increasing function if the derivative, that is dy over dx, is a positive, that is greater than 0 for all x belonging to a comma b. That is f prime of x is greater than 0 for all x belonging to a comma b. So here we have to first find out the derivative of this function f of x. Now see, here we have the greatest integer function, that is greatest integer of x, and here we are given the condition, that is x should belong to this interval, that is 1 comma 2. So we can now write x greater than 1 but less than 2. So when the values of x, it lies between 1 and 2, then the greatest integer of x should be equal to 1, right? And this is due to the definition of greatest integer function. Suppose x is, say, 1.5, right? And 1.5 lies between 1 and 2. So the greatest integer of 1.5 is simply 1. And similarly, if x is say 1.01, then the greatest integer of 1.01 is again 1. So for all x belonging to this interval, the greatest integer of x should be equal to 1. So now our function becomes f of x is equal to x minus 1. So now this is a linear function, right? And if we find the derivative, that is f prime of x, then we have d by dx of x minus 1, and the derivative of x with respect to x is 1, and the derivative of 1 is 0, being a constant, so we have 1. So the derivative, that is f prime of x, is equal to 1 or plus 1, and it is obviously greater than 0 for all x belonging to this interval, that is 1 comma 2, right? So our derivative, that is f prime of x, is equal to plus 1, that is it is a positive quantity, so plus 1 is always going to be greater than 0. So f prime of x is greater than 0 for all x belonging to 1 comma 2. So we can now conclude that our function f of x is an increasing function in 1 comma 2, because the derivative, that is f prime of x, that is dy over dx, if we take this function as y is equal to f of x, so dy over dx is greater than 0. So this function is an increasing function in 1 comma 2.